please let me know. Again, Leo, Tintin, Nidal, Irvin, and Faith. If you're here, please let me know. Oh, thanks, Tintin. Sorry. Oh, Tintin. All right, good morning. Welcome back. I hope you guys are doing well, staying safe, and I hope you had a great extended weekend, a great Memorial Day too. Here we go, back at it. First things first, Tristan, I don't know if you heard me before, but you have to take the post test. The post test is on Buzz. Go to Buzz, log into Buzz from SchoolLink. Once you're on Buzz, you find Chemistry R Brown and find the post test. There is no password for the post test. You need a reference table, you need a calculator, scrap paper, and a pencil. Those 4 things to complete it. That has to be done as soon as possible. It is graded as well. If you need help, please ask for help. All right, what's going on for today? Let's check it out. Quote of the week. Quote from last week. I use it for today as well. Success is dependent on effort. So I love that quote. Whatever you put into something is what you get out of it. I talked about that throughout the year. You put something into it, you put the effort in, you'll get the results you want out of it in the end. Success is dependent on effort. If you're willing to do something in life, if you want to do something in life, you're putting the effort in, you will succeed. Today is not Tuesday. Today's Monday, June 1st, 2020. No, today's Tuesday, guys. Just kidding. Monday we had off yesterday. Today's Tuesday, June 1st, 2021. It is a day 4. That's a typo. And what we're going through today is topic number 4, naming organic compounds. But we're also going through functional groups as well. So we'll go through 2 different topics. We'll wrap up 2 different topics today within the class. Hey, Leo, welcome back. Please try to get here a few more minutes earlier. All right, so a lot going on today. We're going to figure out how to name organic compounds. We'll analyze the examples. We'll do the exit pass questions and the examples together. Once we're set with that, we're going to jump on into functional groups. We'll figure out what a functional group is. But refresher, what is organic chemistry? Organic chemistry is the chemistry of carbons, the interaction, the bonding of carbon atoms. Why are carbon atoms so popular? Because they have 4 valence electrons, and there's room for 4 more electrons to bond within it. Hydrocarbons are H and C's. We know what isomer is. We know what homologous series are. And now let's go through, let's figure out some examples of how to name organic molecules. Please click on the examples above. Maybe you want your notes. Maybe you want the reference table. But start off with the examples above. Topic number 4, naming organic compounds. We'll do these examples together. There's 5 questions here, and then we'll do the exit pass questions together too. I'm going to take the questions, I'm going to take the reference table, and we'll answer these questions. A lot of these you should be able to do. Maybe you need some more practice. Here we go. Question number 1. Again, examples. Topic number 4, naming organic compounds. It's going to be a busy class today, so jump aboard and let's get going. Question number 1 says, which is the correct name for a substance shown? All right, so we have this substance above, and we want to know the name of that compound. All right, so that's a compound. The first thing I would do in this situation is to figure out how many carbon atoms are represented there. How many carbon atoms do we have? There's 1. There's 2. Oh, 2 carbon atoms represents the prefix of F. So it has to start off with F. 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 All right. I can't get rid of anything yet because they're all F for prefixes. The next thing I notice, hopefully next thing you notice too, is the type of bond between the carbon atoms. What kind of bond is it? It is a double bond. Single bond, double bond. Oh, a double bond has the ending -ene. It's an alkene series. It's going to have an -ene ending. That molecule is going to be ethene. Ethane would represent a single bond. Ethine would represent a triple covalent bond between the carbon atoms. Ine, hopefully you know how to do that. Anol is going to be an alcohol attached, which we'll talk about a little bit later in class. Number one, the best answer is going to be choice D. Hopefully you saw that. Next up, number two, what's the IUPAC name for the compound with the structural formula shown below? Can you name this one? Let's do this one together too. First things first, figure out how many carbon atoms are represented. The longest continuous chain of carbon atoms. One carbon atom, there's two, there's three, there's four, and there's 5 carbon atoms. So we're checking out there, we know that there's going to be 5 carbons. Look on the reference table, look for the prefix for 5, which is number of carbon atoms is 5. Has to be pent. All right, so pent is the prefix. Longest continuous chain is 5, therefore it's pent. Now analyzing it. Is there a single bond, a double bond, or a triple bond? Checking out that equation again. There is one double bond in between those carbons. That double bond, check out the homologous series, it's going to belong to the alkene group. Therefore, the ending is going to be ENE. All right. It's got to be ENE, ENE, ENE. It's not ine, that's a triple bond. No. So it's definitely not C, or it's definitely not going to be choice D. Not C, not D. Next up, we have to number the longest continuous chain of carbon atoms. How do we number? We number the carbons closest. We start numbering from the side closest to a double bond or a triple bond. If there's no double or triple bond, we number it from the side where something's branching off. So this situation, where's the double bond? It's closer to the right. We number it from the side closest to the double bond or the triple bond. We start numbering there. This would be carbon number 1. This would be carbon number 2, carbon number 3, carbon number 4, and carbon number 5. This situation, we numbered it from right to left because the double bond's closest to the right. Next up, at carbon number 2, something's going on there. At carbon number 2, you have this double bond. This molecule above would be 2-pentene. At carbon number 2, you have the ene, which is a double bond. Best answer for number 2 is going to be choice A. That is 2-pentene. If you number it the other way, it would be 3-pentene, which would not be correct numbering system. Number 2, the best answer is choice A. Any questions on number 2? Use those rules that we did in class. We put in our notes already. Next up, number 3. Let's check it out. Given the structural formula, what's the IUPAC name of this compound? Again, IUPAC, all that means is International Union of Pure Applied Chemists. A bunch of chemists named this compound. What's the correct name for this compound? First things first, find the longest continuous chain of carbon atoms. 1 carbon, 2 carbon, and 3 carbons. Carbon to carbon connection, the longest chain is 3. Therefore, it's got to be prop. You saw a prefix on the reference table. Prop, prop, prop. I can't get rid of anything there. Step 1, find the longest continuous chain. Step number 2, see if there's going to be a double bond or a triple bond there, or a single bond. What kind of bond is in between the carbons? Oh, there's a double bond. If there's one double bond, it's going to have the ending of ENE. Ene. It's an alkene series. Just by that alone, we know it has to have the ending ENE. This is propene. Propene. Best answer for number 3 is choice B. Ane's a single bond. Anone is a functional group, which we'll talk about later. And all is going to be a functional group too. 3 best answers, choice B. And a lot of these I think you guys could already do at this point. Next one up. What's the correct structural formula for propene? please put the answer in the chat. Which one represents propene? Please record your answer in the chat for number 4. Propene. Please record your answer in the chat once you come up with an answer. Thanks, Kai. Thanks, Nadina. 3 more, please. 22 people on live right now. 3 more responses. Thank you. 3 for 3. 4 for 4. 1 more. What's the best answer for number 4? Wendy, any idea? Oh, D. All right. Thank you very much, Alex. All right. Everybody said choice D. Prop. Check out prop. Prop, again, is going to tell you the number of carbons. Prop tells you 3 carbons. So it's got to be 3 carbons. Definitely not going to be choice A because there's 2 carbons. It's definitely not going to be choice B because there's 2 carbons as well. So it's not A. It's not B because there's 2 carbons. It's either C or D. Propene. The ene's going to tell you that there's going to be a double bond. ENE tells you that there is going to be a double bond. It's got to be choice D. Choice C would be propyne. YNE. 4, the best answer is going to be choice D. Cool. 4 is D. And last one, number 5. Should be an easy one. Which is the structural formula for methane? Please record your answer in the chat. What's the correct formula for methane? I'll wait for 5 responses. Three for 3. 4 for 4. Thanks. 5 for 5. Methane. Easy question. Meth tells you 1 carbon. That's 2 carbons. 2 carbons. That's a methyl group, but not methane. Ane tells you single bonds between them. That is a methane molecule. CH4 is methane. Number 5, best answer is going to be choice D as well. Hopefully you could do those questions. Most of the answers were D here. Hopefully you did them. Okay, cool. That's examples. Let's open up the ExitPass for naming organic molecules next. So please open up the ExitPass, naming organic molecules, ExitPass. Very similar to this last assignment, but we're going to do this one together. So ExitPass, we haven't done any ExitPasses together throughout the year. This one we will. Some of the questions did repeat themselves. There's 5 questions regarding naming organic compounds. Number 1, we saw this one before. Which is the correct name for the substance shown? Again, you saw this. 2 carbon atoms. It's got to be F. There's a double bond there. 1 double bond's ene. Therefore, it's going to be choice D. 1 is definitely D. We saw that one. Question number 2, we saw before. Yeah, we did see this one before. What's the best answer for 2 again? Anybody? Think about it. Put it in the chat. Do you remember how we did this? First things first, find how many carbon atoms. 1, 2, 3, 4, 5. 5 carbon atoms represents pent, 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 pent. There's a double bond there. Double bonds are going to represent Ene. 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 One of those. And you had to number this according to the side closest to the double bond. This all the way to the right is carbon number 1, carbon 2, carbon 3, carbon 4, carbon 5. 2 is the best answer. Yeah, a lot of you guys put that. 2, the best answer is going to be choice A. 2 is A. This is grade 3. What's the best answer for this one? Wants to know the IUPAC name for the compound. Throw in the chat. Should be a quick one. Yeah. Choice B is the best answer. Find how many carbon atoms you have. Figure out if there's a single, double, or triple bond attached. Propene is the best answer for number 3. Number 4, different type of question. What's the IUPAC name for the organic compound that has the formula shown below? This one has a substituent group attached. Take some time to think about this one. Please record your answer in the chat once you have it. I'll wait for 5 responses for number 4. What was D? Again, please record your answer for number 4 in the chat. Once I have 5 answers, we will go over it. All right, several of the same answers. Let's see if that's right. If you don't know how to do it, hopefully you can figure it out real soon. We're almost done with this topic. First things first, figure out the longest continuous chain of carbon atoms. 1 carbon, 2 carbons, 3 carbons, 4, 5. 5 carbon atoms is longest, 4 or 5. There's still 5. So no matter how you look at this, 5 carbon atoms is the longest continuous chain. 5 carbon atoms represents pent. So there has to be pent somewhere in the name. It has to be pent. There's a pent. There's a pent as well. Next thing up, the carbon atoms. How are they attached? Are they attached with a single bond, a double bond, or a triple bond? You can look at all these and say, oh, they're all single bond, single bond, single, single. All single bonds throughout the carbons. A single bond is an alkane. Ane. A-N-E is going to be the ending. It has to be ane for the ending. All right, now we have a 50-50 shot at getting this right. We got rid of choice A because there's no pent in there. We got rid of choice C because there's no pent in there too. Next thing we have to do is figure out how to number this thing. Are we numbering it from right to left or left to right? We number it from the side closest to a double bond or a triple bond. If there's no double or triple bond there, you number it from the side closest to something branching off. All right, something branching off. There's something branching off over to the right. Hopefully you know that's 1 carbon atom attached. That is a methyl group. It is a substituent group attached to the parent chain. So it's definitely a methyl. Methyl, there is the methyl. I color coded this so it's really easy to see. Now we have to number this thing. All right, we number it from right to left because something's branching off closest to the right. This is carbon number 1, this is carbon number 2, carbon 3, carbon 4, carbon number 5. The methyl group is coming off of carbon number 2. That's the correct way to number it. This answer is going to be 2-methyl pentane. That is 2-methyl pentane. Number 4, the best answer is choice B. 4 is B. Hopefully you see what I did there. Hopefully most of you guys got this, so nice job. If you don't know how to do it, hopefully you're understanding or paying attention to class right now. Hopefully you're not gaming or on your snap. Choice B is the best answer for number 4. Last question here. Number 5, it says, give the formula for the organic compound. What is the name of the group in the box? Super simple question. What is the name of that substituent group in that box right there? Please record your answer in the chat. All I want to know is what's the name of that group. Two carbon atoms attached. It's a substituent group. It's going to be ethyl group. Yeah, ethyl group is the answer for that one. Choice B is the best answer. Please submit your work. Should have gotten a 5 out of 5. That is an easy quiz grade since we did it together. Any questions on how to name organic molecules? All right, next up, please open up your guided notes. Go to your guided notes, please. We're going to finish up naming organic compounds, and then we'll jump into functional groups as well. Before we get into functional groups, let's scroll on down. Let's get to the rings, the next portion where we left off. Let's review where we were before. It's like almost a week ago before. So we already talked about topic 1, organic basics and hydrocarbons. We said organic molecules are going to be carbon atoms that are covalently bonded together. They can form chains, rings, or networks. We said carbon atoms are very popular because there's 4 valence electrons, and there's room for 4 more electrons to make a stable octet. We talked about single bond, saturated. We talked about double and triple bond or unsaturated. We named those 2 or 3 molecules. We talked about different formulas. We said a molecular formula tells you the total number of atoms present. We said structural formulas is a kind of atom present in a compound. It shows you the type of bonding. Condensed structural formula tells you what is attached to each carbon atom. The ball and stick model shows you the bonding pattern. It also shows you which kind of atoms are bonding and the bond types. And then we talked about hydrocarbons. A hydrocarbon is going to be hydrogen and carbon only. We talked about properties of hydrocarbons. We named some hydrocarbons. Topic number 2, we talked about homologous series. We said alkanes, alkenes, alkynes. A single bond, a double bond, a triple bond. AEY. Alkanes, single bond, saturated. Alkanes release energy. We said they release energy when they burned. We talked about alkanes with the formula CnH2n plus 2. We figured out how to use that formula to figure out an alkane series. We looked at alkenes, double bond, unsaturated. The ending is going to be ENE. We looked at the formula CnH2n. We figured out how to use that formula too with several examples. We looked at alkynes, a triple bond, unsaturated. The ending's YNE. The formula CnH2n minus 2. And we also looked at some examples of alkynes. We said an isomer, topic 3, was same molecular formula, but a different structural formula. Topic number 4, we figured out how to name straight chain molecules. We figured out how to name branch chain hydrocarbons. Found the longest chain. You found a substituent group. You added the correct endings to the substituent groups. You numbered them. You figured out how to name the parent name. You figure out how to name the substituent group, and then you figure out how to number them in alphabetical order. We figured out how to name an organic molecule from examples. There's a straight chain. We did a more complex one, 2-methylhexane. We did another complex one, 3-ethylhexane. And then we did 3-ethyl, 3-methyl pentane. You name that one. You also named 2,2,4-trimethylpentane. Pretty complex one there that you named in class. Last class, what do? We drew some organic molecules. From a name, you drew some organic molecules. We did that. This is the only portion of notes that doesn't have to be completed. I did this under Elmo. I said, we're not going to draw it in Google Forms because it's going to take forever. I drew it under the Elmo. Hopefully you copied your notes down. You could upload the picture to this section. I am not going to penalize you if you don't have the pictures in your notes. So drawing these organic compounds, cool to know. But I am not going to penalize you when I grade them if you do not have them. This example too. If you don't have this example in here, I'm not going to penalize you if you do not have it. Good for practice. You might want to practice someone up, see if you can do that. That's a good reference point. So do you know how to do these things? Could you look at this molecule, this ball and stick molecule? Could you figure out the molecular formula? Could you figure out the structural formula? Could you figure out the empirical formula? Could you draw a structural formula from that? Could you make a Lewis dot diagram for that too? Maybe you want to complete it. You don't have to. I will not penalize you if that's not in your notes. Next up for today's class, we're talking about rings. So let's go through and talk about organic rings. A few different types of rings that we're going to look at. Organic carbon rings. Carbon rings. They can be alkanes, alkenes, and alkynes. All contain carbons in the linear chains. There are also hydrocarbons arranged in rings. Hydrocarbons can also form rings. Hydrocarbons can also form rings. Organic molecules can form chains. We did that. Rings, which we're talking about today, and networks. The first example of a hydrocarbon in a ring is going to be cyclohexane. 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 Oh, hexane. We know that is. We can figure out what hexane is. Cyclo. Think of maybe you hit for the cycle in softball or baseball. You're going all the way around the bases. Cycle goes full circle. The formula for a cyclohexane is going to be C6H12. C6H12. Cyclohexane molecular formula is going to be C6H12. Below, I have some examples of cyclohexane. You can see it's a hexagon. Carbon 1, 2, 3, 4, 5, 6. Every carbon here has 2 H's attached. There's a structural formula. There's a shorthand version of a cyclohexane. And then there's a ball and stick model. What's up? C6H12. The formula is C6H12. The red stuff. It was a font too small. There we go. Hopefully that's better. All right, so there's a ball and stick model, there's a shorthand version, and then there's a structural formula for this. The description of a cyclohexane. It's going to be a saturated hydrocarbon with a hexagonal ring. So saturated means all single bonds there. Saturated hydrocarbon with atoms arranged in a hexagonal ring. Hexagon. Hexagonal. So all single bonds are connected between all the carbons. You can see that from the structural formula in the description above. The presence of hydrogen atoms are often assumed, and this compound can be represented by a hexagonal ring. So at the end of every corner here, or intersection, or every angle here, there's going to be a carbon atom. It's not always inferred that there's a carbon atom there. This is a shorthand version of the cyclohexane. So there's a carbon here. Every angle where it changes, there's going to be a carbon represented. it's also inferred that there's going to be two H's attached to it as well. So there's going to be two H's branching off, two H's branches off, two H's branches off. But it's not always represented like this version here. That's a shorthand version of cyclohexane. First ring, done. Second ring. Next ring is going to be benzene ring. Stay with me, I have a lot to do today. Benzene molecule, very popular organic ring. The formula for benzene is going to be C6H6. 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 It's a 1-to-1 ratio for carbon and hydrogen. With that 1-to-1 ratio, there's going to be double bonds between every other carbon atom. There's 4 different versions of a benzene. There's a structural formula for benzene. There's another structural formula without the H's for benzene. And then there's a shorthand version of benzene. And then there's a ball and stick model for benzene. You could look at each example. You see a double bond, a single bond, double, single, all throughout the organic molecule. They switch, double bond, single bond. This is a shorthand version. A hexagon with a circle around it represents a benzene too. Description of benzene. Benzene is going to be an industrial solvent. An industrial solvent. It's going to be a benzene ring. Benzene rings. So fill in the blank below. Benzene rings. Benzene. One of the most important structures in organic chemistry. So you go on to college chem, you probably will learn about the benzene ring. You take organic chemistry, you will definitely learn about the benzene ring. The impacts that benzene has on organic chemistry, huge. It's going to be a double bond and a single bond are spread throughout. It alternates a double bond and a single bond. So fill in the blank, alternates the double and single bond, which are spread throughout the ring so that the molecule is symmetrical. Cut this thing in half, you have the same thing on both sides. A lot of organic molecules are going to be symmetrical. If they're symmetrical, it's going to tell you it's nonpolar. If it's asymmetrical, meaning it's not the same thing on both sides, it's probably going to be a polar covalent bond. So polar, nonpolar, covalent, hopefully you know what those terms mean. Covalent, 2 nonmetals bonded together. Nonpolar, it's going to be symmetrical, means the electronegativity is less than 0.3. If it's polar, still 2 nonmetals, the electronegativity is going to be 0.3 to 1.3. 1.3 to 1.3 or 1.7, I can't remember now. 1.7, 0.3 to 1.7. And a benzene ring is represented by a hexagon with a circle. Hexagon with a circle inside. Benzene, quick, easy. You have the drawings represented there for you. That's a benzene. Next up, next ring we're going to analyze is going to be toluene. 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 This organic green, you know something about it. The ending's ene. So you should know that there's a double bond somewhere throughout this. Toluene molecule, the formula is going to be C7H8. 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 Toluene molecule. What's going to happen here? You have a hexagonal ring, but you also have a methyl group attached to it. So methyl is 1 carbon CH3. 1 carbon and 3 hydrogens attached to the benzene ring. There's a structural formula. There's a shorthand structural formula. There's another one. And then there's your ball and stick model for toluene. Toluene, important solvent and starter chemical. Solvent and chemical starter. Starter chemical. So this is going to be like a catalyst used to start chemical reactions. It can be depicted with a benzene ring, described as a benzene ring with a methyl group. A benzene ring with a methyl group attached. You could see that too. Cool. And the last ring we're going to have to copy in our notes just to make our notes complete is naphthalene. Stay with me, folks. I'm going to add this to the next page just so it's all on the same page together. The last ring, naphthalene. NaPH, THALENE. Ene. The formula for this is going to be C10H8. 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 Ene. You see ene at the end. You know that there's going to be a double bond. Here's a couple structural formulas for C10H8. Structural formula, shorthand structural formula. There's a ball and stick model. And then there's another representation for naphthalene. Naphthalene. It's 2 benzene rings fused together. Naphthalene is going to be in mothballs. They can be represented as 2 benzene rings fused together. 2 benzene rings together. And that is the last ring that you should be aware of. But are they going to ask you any questions about the rings on the final exam? No. You don't have to memorize those. So these rings you don't have to memorize. They're good to know for the future. And I just did it to complete your notes. But there are rings in organic chemistry too. Yeah, Joe, I'll readjust it. I'll go through it and check it out. Yeah, yes. All right, that takes care of naming organic compounds. Again, you do not have to memorize these. You don't have to know how to draw them. They're not going to be asked on exit passes. They're not going to be asked on the final exam, nothing. Next time you might see them is in college chem or organic chemistry in college. Maybe AP Chem, if you take AP Chem next year. Cool. All right, next up is topic number 5. We have 40 minutes left to class, and we will go through topic number 5. We'll figure out all this stuff. The thing is, it's going to fly by so quick because there's not a lot of notes. We're going to be talking about functional groups. So now we're talking about like a parent chain with something else attached, not a substituent group, but a functional group attached to it. We'll figure out how to identify these. We'll figure out how to name these things all within the examples. So we're going to cruise through this, but before I do, I'm going to play a video on nomenclature. Naming organic molecules. Here you go. Take a break. After this,
there's some of you out there taking chemistry and feeling a little bit like there's an international body whose job is simply to make your life more difficult, to force you to cram tons of information, all the wonder and excitement out of learning about how the world works at this beautiful fundamental level of chemicals. You are not actually imagining this. That organization actually exists. It's called the International Union of Pure and Applied Chemists, or IUPAC, and really they're looking out for your best interests. In just the same way that my mom was looking out for my best interests when she said that I couldn't go to the Violent Femmes concert with Megan Cross. And yeah, I hated my mom for like a full year after that, but she was right. That girl was trouble. So yes, you are allowed to hate IUPAC for changing the name of cinnamaldehyde, the aldehyde that makes cinnamon smell like cinnamon, to trans-3-phenylpropanol. Yes, they're sucking all of the fun out of the world, but trust me when I say, they're doing it for your own good. Cinnamaldehyde is a lovely name for a lovely aldehyde, just like cadaverine is a creative name for a rancid-smelling amine. Citronellol, angelic acid, vanillin, they're beautiful names, but there are tens of thousands of regularly used organic compounds, and we can't come up with pretty names for all of them. More important than that, though, there's no way to translate those names into chemical formulas. And IUPAC hates that. They're like, cinnamaldehyde, yeah, sure, it gives cinnamon its lovely smell, but we think that trans-3-phenylpropanol is way better of a name. And it actually is, because if I say trans-3-phenylpropanol to somebody properly educated, they can just write down the chemical structure without even thinking about it. And that's like almost a kind of magic, where words go from relating to reality as we experience it, this chemical comes from cinnamon, so name it after cinnamon, to relating to the actual physical reality of the universe. And that's a magic worth knowing. IUPAC created a language that could be understood by everyone with minimal, even zero misinterpretation, and that's no easy feat. That's why, as we've discussed organic chemistry, when we start counting carbons, we make sure that the first thing named on the molecule is the lowest possible carbon. Not because there's something special about lower numbers, but because they had to make a rule, otherwise one chemical could be named two different ways. Let's go through the process of naming a chemical. It's a multi-step process. Step 1. How long is the carbon chain? 5 carbons will have pent, 7 sept, 3 prop, 1 meth. Don't feel weird if you have to look these up. I, for example, had no idea that a 23 carbon atom chain had the prefix tricosa until I looked it up just now. The only tricky thing here is to make sure you find the longest carbon chain. Sometimes a hexane can look like a pentane with an ethane sticking off of it. So now that you know your longest carbon chain, you've got your prefix, time to figure out the suffix. If there's nothing but hydrogen and carbon, your suffix just depends on whether you have any double bonds or triple bonds. You know these: propane, propene, propyne. Then there are a ton of other groups that can change the suffix. Like last week we talked about alcohols and aldehydes and ketones, but we didn't talk about how they affect nomenclature, and boy do they. When working with functional groups, each one adds a particular suffix to the end of the name of a compound. Usually these are pretty easy to remember because they come straight off of the name of the functional group. Alcohols add an OL, so for methane you drop the E and you get methanol. Ethane, you get ethanol. Aldehydes, instead of all, you add al, so from ethane you get ethanal. Ketones add -one, so a ketone of a hexane would be hexanone, and amines, you just add amine to the end, so methanamine or propanamine. Super easy. For carboxylic acids, you have to identify that it's an acid, so you end in acid. That's obvious. But instead of adding ilic, you add oic. As far as I can tell, this is just because ethanoic acid is much more fun to say than ethanylic acid. Going over that again. Alcohol on an ethane is ethanol. Aldehydes add al, giving ethanal. Ketones add O-N-E, pronounced ethanone. Amines add amine for ethanamine. And carboxylic acid on an ethane is ethanoic acid. And of course, there are literally dozens of other named functional groups that will change the suffix. It's terrible. That's why they're on Wikipedia. So if you got a functional group, there's a name that defines the suffix of the molecule, and that is called the parent functional group. Now, it is perfectly possible that a molecule will have 2 different functional groups, so how do we know which one is the parent? Which one defines the suffix? Well, different groups have different precedents. The most weighted of all is the carboxylic acid functional group, so no matter what else else is on a 6-carbon chain. If there's a carboxylic acid, then it's a hexanoic acid. That precedence is decided by a list that was, you guessed it, created by IUPAC to minimize confusion by creating yet more rules. The list is linked in the description. Okay, so now we have created our base name for the molecule. It's time to start looking at what else is attached to it. Any side chains or functional groups sticking off the side have to be identified and named. If it's a 6-carbon chain with a carboxylic acid on it and an alcohol on one of the other carbons, our name has to do 2 things. Identify that the hydroxyl group is there and identify where it is. If it's got a double bond, we likewise have to identify that it is there and where it is, all with our words. Use your words. Also, use your numbers. Counting out carbons can be a little confusing, but try it both ways in both directions to make sure you get the lowest possible number on the group that defines your suffix. Alright, enough of the talking. Let's try to do some actual examples here. I mentioned earlier angelic acid. It's not actually particularly angelic, it's just named after a flower that it was derived from, but it's actually all over the place in nature, so angelic acid tells us pretty much nothing about the molecule, except that it's acidic. So in order to figure out the structure, I have to look it up. That's no fun, but here it is. Let's figure out a better name for it. Count out the carbons. 1, 2, 3 if you count that chain. 1, 2, 3, 4 if you count this one, so it's a butane derivative. Actually, it's a butene derivative because it has that double bond. It's also got the carboxylic acid though, so let's go ahead and call it butanoic acid. Except that there's a methyl group sticking off, so it's methylbutanoic acid. Of course, with that name, without any numbers, no one has any idea where anything is on the chain, so time to number. From this direction, 1, 2, 3, 4, we get 3-methyl-but-2-in-4-oic acid, which is obviously wrong. Mostly because that parent functional group, the one that defines the suffix, is supposed to be as low as possible, and in fact it is as high as possible, so that can't be right. Also, it just sounds terrible. Numbering the other way, 1, 2, 3, 4, the carboxylic acid is on carbon 1. That's pretty ideal. The double bond and the methyl group are both on the 2nd carbon, much better, and thus it is named 2-methyl-but-2-enoic acid. 2 important notes here: if a parent functional group is on carbon 1, we just leave the number off. And 2, there's a double bond in this molecule and we haven't identified whether it's cis or trans, and we can't do that, so we haven't actually completely named it. We should stick a cis in front of the name because the carbon chain continues on the same side, not the opposite side as it would be in the trans form. Of course, it works both ways. That's the beauty of it. You can build a name from a molecule and a molecule from a name. Earlier, I told you that cinnamaldehyde was trans 3-phenylprop-2-enol. Can you build it? Well, start with a 3-carbon chain because of that prop, and count out the carbons. 1, 2, 3. We know because it's prop-2-enol with that E, there's a double bond from the 2nd to 3rd carbon, and we know it's trans. We also know that there's a phenyl group on the 3rd carbon. The word ends in a non-numbered al, so finally we can stick an aldehyde on carbon number 1. And yeah, that was actually pretty easy. Now, look, IUPAC does its best, but past a certain point of complexity, no one expects anyone to know all of this by heart, unless you work for them and name compounds for a living. That's why we have the internet and textbooks and libraries to go look things up. Because I'm a dork, I actually find these things to be kind of delightful puzzles, and they're often super fun for me, but taken 1 or 2 steps beyond the level of complexity we have here, my personal viewpoint is that you're better off looking it up than memorizing the novel-sized list of functional groups, names, precedence lists, prefixes, and suffixes.
All right, I'm gonna stop that video right there today. Let's go on forward and figure out what is a functional group. You can watch that video over and over again. Hopefully you know how to do most of that stuff within that video. So please open up your guided notes one more time. And today's class, the rest of today's class, we're gonna go through, we're gonna analyze these functional groups. So on the reference table, you definitely want that handy too. The reference table, what we're gonna do, we're gonna take a look at table R. So there's this big table, it's called functional groups. And on this table, these are different things that can be attached to organic molecules. What we're gonna do today, we're gonna go through each one of these charts. We're gonna figure out each of the classic compounds. We'll figure out the functional group, we'll figure out the general formula. We'll also interpret or analyze an example. So I'm gonna leave that open for the rest of today's class too. Just gonna put this side a little smaller. This one piece of paper that's on the reference table that we have not gone through, we're going through today. It's page 8, organic functional groups. Hopefully you're ready. We're gonna go fast. We're gonna figure out what these are. All right, topic number 5, organic functional groups. I'm gonna put this all on the same page, start fresh. Topic number 5, functional groups. Functional groups are groups of atoms that are given organic series, give organic series its distinctive character. So each one of these functional groups give its properties that are different. So groups of atoms that give an organic series, its distinctive characters. So yeah, some of these are going to be used for like making alcohol. Some are going to be used for making soaps, esters, making special scented fragrances. They have different properties for each organic functional group, making plastics. So organic series that give it its distinctive character. And these functional groups are listed on the reference table. When oxygen and nitrogen are added, if you have nitrogen and oxygen or nitrogen added, there's going to be more organic reactions that you could have. It gives you a lot more variety of the types of reactions that you could explore. When oxygen and nitrogen atoms are added to a hydrocarbon or a parent chain, organic molecule, there's a variety of compounds that grows. It's going to grow enormously. Again, we're going to check out this page on the reference table. There's going to be different classes, different functional groups, general formulas, examples, all that's going to be outlined right now. So here we go. The first one up we're going to analyze is going to be a halide. The first functional group. Let me just show you exactly what we're going to look at. We're going to check out functional groups. The first one is going to be a halide. Right there. So we're exploring the first column, first row. So halide or halocarbons, when you have an organic compound with an F attached to it, it's going to turn to fluoro. That's going to be the prefix in front. Or if there's a chlorine attached to a hydrocarbon, it's going to be chloro. If there's a bromine attached to a hydrocarbon, it's going to be, hey, bromo. If you have an iodine attached to it, you can check out the reference table. If it says iodo, it's going to be iodine is attached to the hydrocarbon. Another thing to note is the R. The R represents an organic molecule. X represents a halogen or a halide. So if you have an organic compound and an F, it's going to be a halide attached to an organic compound. The first one up, the structural formula we're going to analyze. First one's going to be CH3. CH3, CH, Cl, CH3. The name of this organic molecule, that structural formula, CH3, CH, Cl, CH3, it's going to be 2-chloropropane. You can see where I got the name, the structural formula, condensed structural formula. You have the name. The name is going to be 2-chloropropane. 2-chloropropane. You see the example is given to you right there in the reference table. And then we're taking some notes on functional groups. The structural formula is represented. I have the examples already listed for you right in the notes. You can see how that's 2-chloropropane. The ball and stick model is a better representation. Prop, maybe you want to separate it a little bit. You can separate it. It's okay. Prop tells you 1, 2, 3 carbon atoms. Ane tells you single bonds. And at carbon number 2, there's a chlorine attached to that too. 2-chloropropane. If that was a fluorine there, that'd be 2-fluoropropane. Notice how the halide is represented in the front of the equation. First thing listed. Okay, scroll on down. We're done with halides. Next group we're going to analyze is going to be an alcohol. This one's going to take a few minutes to copy down. There's a little bit more about alcohols. Alcohols, next functional group. Scrolling. Functional group, the class of the compound is called alcohol. The functional group attachment is going to be an O and an H. So OH. Yeah, we saw OH before. You saw that as hydroxide. But when OH is attached to a functional group or organic compound, it's going to represent an alcohol. The general formula for an alcohol, you're going to have R, which represents the organic reaction. So R represents the organic reaction or the parent chain, and attached to that is going to be OH, which is going to be an alcohol. The name or the example we're going to analyze is 1-propanol. 1-propanol. 1-prop and all. 1-propanol is the example we're going to analyze. We could break this up. We know prop tells you 3 carbons. And, oh, it's not ane, but it's all. If you have, oops, OL, not AL. If you have OL ending, it's going to tell you it's going to be an alcohol attached to it. Where is the alcohol? The alcohol is going to be attached at carbon number 1. So at carbon number 1, you have an OL. OL is going to tell you it's going to be an alcohol or an OH attached to it. So here we go. Let's check it out. I have the condensed structural formula represented, CH3, CH2, CH2OH. The name, you drop the E, so it's not alkane, it's going to be OL for the ending. The ending is going to be OL ending. That's key there. So again, drop the E from the name, the last name, drop the E, and you add an OL instead. OL ending tells you it's going to be an alcohol. There's an example. This is 1-propanol. 1-propanol, represented right there. Prop, 3 carbons, and single bonds. OL tells you the functional group attached to that. There's 1-propanol. More information about alcohols. Example number 2, there's methanol. Methanol. All right, methanol. What the heck's methanol? Meth tells you 1 carbon, okay. And tells you single bonds. All tells you that there's an alcohol attached. Methanol. Right there. Organic molecule with an alcohol attached. Ethanol. Next one. Eth tells you carbons. You have 2 carbons. And tells you a single bond in between. And that's a single bond. And then all tells you there's a functional group of an alcohol attached to that too. Ethanol. Hopefully you can see that one. Classifying alcohols. They may be classified according to the number of OHs. Number of OH groups or alcohols in the group. If there's 1 OH group, 1 OH group is going to have the ending OL. So there's only 1 alcohol attached. It's going to have an easy ending of OL ending. If there's 2 alcohols attached to a group, it's going to have the ending di. Di refers to 2. To what? 2 alcohols. Diol. 2 tells you, di tells you that there's 2 of them. OL just says, hey, there's only one alcohol attached. If there's 3 alcohols attached to a parent chain, is that tough to see? Diol. If there's 3 alcohols attached, what's going to happen? It's going to turn into triol. So tricycle has 3 wheels. So 3 what? 3 OLs, 3 alcohols would be attached to a group. So definitely a little bit tougher of a concept, like you guys to see it, but you don't have to worry about doing that. More information about alcohols. If there's a primary alcohol, primary alcohol is going to have the OH group bonded to the primary carbon atoms. Carbon bonded to one other carbon. Primary, there's one other carbon atom. Primary alcohol, referring to 1. If there's a secondary alcohol, it's going to be bonded to 2 other carbons. And tertiary. Tertiary alcohol is going to be to the 3rd carbon atom. 1, 2, 3. Boom. Primary, secondary, tertiary alcohols. There's an example for primary, 1 carbon atom, secondary, 2nd carbon atom, tertiary, 3rd carbon atom. 3 carbon atoms attached with alcohol. All right, a lot of information about the alcohols, but we're done with that functional group. Alcohols, done. Let's jump to the next functional group, which is going to be an ether. Ether functional group. 3rd one down, ether. Told you I was going fast today. But I think once you guys really understand these, you will understand the functional groups. It's pretty easy after you get some practice. Next classic compound is going to be an ether. Ether is going to have an oxygen smushed in between the organic parent chain. Ether, you have carbons on both sides of the oxygen. Ether. So again, R's represent carbons. You have an oxygen smush in between the organic chain. The condensed structural formula is going to be CH, an example is going to be CH3O, CH2, CH3. The example below, or the example in the reference table, is methyl ethyl ether. Methyl ethyl ether. Break it on down. Methyl, think of methyl. Methyl refers to 1 carbon atom. Ethyl refers to the parent chain. There's an ethyl. Nope. Hold up. Ethyl refers to 2 carbon atoms. Ethyl. Oh, 2 carbon atoms. There's my ethyl. And ether refers to the functional group. Functional group for an ether is an oxygen smushed in between 2 carbon atoms. That's the ether. Methyl, 1 carbon atom. Ethyl, 2 carbon atoms. Ethers and oxygen smushed in between. There's your functional group. Methyl ethyl ether. There it is. Ethers have oxygen atoms attached to 2 hydrocarbon chains or rings. The group attached to the ethers are named in alphabetical order. They're named in alphabetical order and are followed by the word ether. Named in alphabetical order and are followed by the word ether. Alphabetical order and are followed by the functional group ether. Followed by ether. Ether. The naming system's a little bit different. Well, you can figure out this by just looking at the reference table. Look at the key, look at the examples in the reference table, and then you'll figure out a basic idea of how to name this. Second example. Let's check it out. Second example, we have the organic molecule. All right. There's CH3. There's 2 moles of CH3 and an O. So the example, here we go. First things first, let's look at it. Let's break it on down. We have a methyl group. We have another methyl group, but we also have an oxygen in between. So we have an ether. Okay, so this name of this molecule is going to definitely be methyl. There's got to be methyl somewhere. And the ending is going to have to be ether. But we have one methyl group, we have another methyl group. This would be dimethyl ether. 2 methyl groups and an ether. That is the name of that organic molecule. Dimethyl ether. Cool. Let's try another one. Example number 3. Figure it out. Let's think about this process. The first thing we have is how many carbon atoms? 1, 2. This is going to be ethyl. We have 2 carbon atoms again, which is ethyl. So it's definitely ethyl. Ethyl. How many ethyl groups do we have? We have 2. Therefore, it's diethyl. And then in between the ethyl groups, we have an ether group. Diethyl ether. Diethyl ether is the name of that organic molecule. Diethyl ether. There's another example. Diethyl ether. Pretty cool. Cool stuff you could say that you could name. Not many people could name something like that. Maybe you could with more practice. Maybe you could right now. Maybe you understand that. That is an ether. Next functional group, moving on forward. It's going to be aldehyde. Aldehyde. So here we go. Next functional group. I know we're cruising, folks. Bear with me. I'm recording class today in case I do go too quick. You have to rewatch the video. It's all here for you. Next class is going to be an aldehyde. Aldehyde group. You can see what's attached with an aldehyde. You have a carbon with a double bond of O. You have an H. A carbon with a double bond of O and an H. The condensed structural formula here is going to be CH3, CH2, COH. All right. The name of the example we're going to analyze is going to be propanol. Prop and Al is going to tell you which functional group it is. Propanol. Break it on down. Prop tells you 3 carbon atoms and tells you single bonds between the carbon atoms. The Al ending tells you what is attached. The ending for an aldehyde is Al. Propanol. 3 carbons and tells you single bonds between them. Al is going to be the functional group attached. There's the functional group for an aldehyde. What happens with the name here? You drop the E. Drop the E ending and add Al. Al. Drop the E and add Al. AL ending, added. Examples for an aldehyde. We have methanol, Al. You see the ending. Al tells you the functional group for an aldehyde. Al ending, you can find the aldehyde. Meth tells you 1 carbon atoms. The Al ending tells you the aldehyde, which is right there. Methanol. Ethanol, second example. You have F, 2 carbon atoms, and single bonds. All Al tells you the functional group attached. Right there. C double bond with O with an H. Example number 4. Propanol. All ending Al tells you the function group of C double bond with O and an H. There it is right there. 3 carbon atoms, single bonds, aldehyde attached. That's aldehydes. Examples given there for you. Next up is a ketone. Ketone functional group. A ketone functional group, what happens here, there's a double bond with C and O. The double bond of C of O is attached in the middle of an organic compound. You can see that. You have the example 2-pentanone, 2-pentanone. You can see the ending is ONE. Let's look up a structural formula for 2-pentanone. So I'm going to take this name, I'm going to copy it. I'm going to go to a new file. I'm going to paste into Google Toolbar. I'm going to look up an image for 2-pentanone. I'm going to take this image right here. Or this one. I'll take this one actually. It's more relatable for you guys. I'm going to copy this image. Copy image. I'm going to paste it within that section of your notes. Find an example of 2-pentanone. Paste it on into your notes. There it is. That's 2-pentanone. Could you draw this yet? 2-pentanone. Think about this. Pent tells you the number of carbons. 1, 2, 3, 4, 5. And tells you single bonds between the carbon atoms. They're all single bonds in between. And then the ending, ONE, is going to tell you which functional group is attached here. Ketone. It's a C with a double bond of O. So when I say looking for the functional group, you look for the odd man or the difference between a hydrocarbon. The C and O is a difference here. This O tells you it's going to be a ketone group attached. Ketones have a C and an O group attached to 2 hydrocarbons or rings. You drop the E and you add ONE. Drop the E ending, so it's not ane, een, or ein. Drop the E and you add the ending ONE. When you find the ending ONE, own, not one, own, that ending is represented, it's going to be a ketones represented there. Example number 2 would be propanone. Propanone. Break it on down. Prop tells you the number of carbons, 1, 2, 3. Prop is 3. And it's a single bond. Own tells you the functional group that you have attached here. What's a functional group? It's a ketone. Own. There's a second example. Next up, next example is going to be an organic acid. Doesn't look like we're going to finish this whole section today. We'll try to do 2 more. Organic acid, next class of compounds, organic acids. Organic acid, the functional group, you have a C double bond with O, and you have an OH. If you ever have this attached, C double bond with O, OH, it's going to tell you it's an organic acid. The example we have is propanoic acid. propanoic acid. C double bond with O with an OH. Organic acid that contains a cool group, they call it, to a hydrocarbon or chain. Drop the E ending. How does it work? Drop the E at the end, and you add oic acid. Drop the E, and you attach oic acid. Oic acid. That one should be an easy one to figure out. You see oic acid, that's definitely different there. Use your reference table. You see, oh, oic acid, it's got to be an organic acid. Organic acid is going to be C double bond with O, OH. Second example is there for you. We have methanoic acid. Meth is one carbon. Oic acid, there's your cool group. Ethanoic acid, 2 carbons. Oic acid, there's your cool group, COOH. Propanoic acid, prop, 3 carbons. Oic acid, there's your cool group. There's organic acids. Ester, next functional group, ester. Ester will make blue. Delay in my system today. Ester is going to have a C double bond with O and an O. C double bond with O and an O. It's smushed between 2 carbon atoms, like an Oreo cookie. The condensed structural formula, here we go, CH3, CH2, COO, CH3. The name of this organic molecule would be methyl propanoate. Methyl propanoate. Methyl propanoate. The example of the structural formula is represented below. Methyl, there's my methyl group. Prop is 3 carbons, 1, 2, 3. O8, draw us in here. O8 would be the functional group for an ester. There's my O8. O8, 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 smushed in between the organic chain. Description of this, the ester contains a COO group attached with 2 carbon atoms, hydrocarbons. It's formed from organic acid and an alcohol. These esters typically are sweet smelling. They're used for perfume, soaps to give it a nice fragrance there. The name, I'm going to change this up. Drop the E. Drop the E ending. I'm going to change this a little bit and change it. Change it. Oof. Change it to. Oh, wait. Drop the E, change it to 08. So I got rid of some of that right in the example. Make it a little easier. Drop the E and change it to 08. Second example. Methyl ethanoate. Break it on down. Methyl ethanoate. Methyl ethanoate. You have CH3, COO, CH2. Methyl ethyloate. All right, folks, I know I did a lot there. We went through everything but the amine and the amide for today. Next class, we'll go through the amide. We'll go through amide. We'll also finish up the rest of this unit tomorrow. All right, guys, that's it for today's class. Stay safe out there. Enjoy this weather. It's going to get really nice real soon. Next week, it's going to be like 90s again. All right, guys, stay safe. Make good decisions. See you guys next time. Bye. Have a good day. I know. Can you reach the bell? See you guys. Have a good day. Bye, Wendy. Bye, Santino. We'll see you later, guys. Bye.